All right, let's just jump right into it. Welcome to this over-the-shoulder explainer. Think of this as your senior developer mentoring session on how to escape tangled, monolithic code and build truly scalable Spring Boot RESTful APIs. We're going to tackle the absolute foundational concepts you need to master so you can stop writing code that constantly fights against you. We'll be breaking down dependency injection, bean management, and the layered architecture that keeps your business logic perfectly organized.
We've all been there, right? A small team kicks off a project, and bam, within months, it has totally devolved into pure spaghetti code. You open up a code base, and instead of finding nice, clear, modular files, you're staring at a massive, thousands of lines long file that handles HTTP requests, database queries, and complex math all in one place. It is a nightmare to test, a nightmare to debug, and virtually impossible to scale. And honestly, this happens simply because we lack a solid structural blueprint.
So how do we fix the spaghetti mess? Well, we rely on the absolute core engine of Spring Boot, inversion of control using dependency injection. In standard old-school programming, if Class A needs Class B to do its job, Class A creates Class B. It's hard-coded right in there. But with dependency injection, we completely invert that control. Class A simply says, hey, I need Class B, and the Spring framework hands it a fully built Class B. It's like you aren't building the engine inside the car, an external factory is dropping a fully built engine into the chassis for you. This promotes loose coupling and makes your application infinitely easier to maintain.
The really crucial takeaway here is that instead of you using the new keyword all over your code base, Spring manages these objects, which we call beans, for you. When your application boots up, Spring scans your code, identifies these components, creates them, and holds them in its inversion of control, or IOC, container. It completely handles their entire lifecycle. That means you can finally stop playing memory janitor and focus entirely on the actual business logic. Whenever a part of your app needs one of these beans, Spring just injects it right where it needs to go.
Yeah, you definitely have options for how to actually inject these beans, but let me tell you, they are not all created equal. You might see field injection out in the wild, using the @AutoWired annotation directly on a class variable. It looks super clean because it's less typing, but it's actually highly discouraged. Why? Because it hides your dependencies and makes unit testing much, much harder. Instead, you really should always use constructor injection. By passing your dependencies through the constructor, you ensure that the object literally cannot even be created without its required dependencies. It promotes immutability, and it makes mocking in your unit tests an absolute breeze.
Okay, so how do we actually tell Spring which classes should become these magically managed beans? We have a standard annotation toolbox. While @component is your generic all-purpose annotation, Spring gives us highly specialized versions to clarify our architecture. @service tells Spring and your fellow developers, hey, this handles business rules. @repository says, I talk to the database. And @controller says, I handle incoming web requests. Using the right annotation at the exact right time is your first step to clean, readable code.
Let's zoom in on the web layer for a second. These days, @REST controller is basically the undisputed king of modern APIs. Back in the classic Spring MVC days, @controller was used to render HTML templates. But today, we're usually building RESTful APIs that return JSON. If you just used @controller now, you'd have to annotate every single method with @responseBody to tell Spring, hey, don't look for an HTML template, serialize this raw data. @REST controller just combines both of those for you. It automatically serializes your return objects directly into the HTTP response, saving you a ton of boilerplate code.
When you start snapping these specialized beans together, you get this beautiful, grand design, the layered architecture. I want you to think of the controller as the waiter taking the order, the service as the chef, and the repository as the pantry. The HTTP request comes in from the client, and the waiter, your controller, takes it. But the waiter doesn't cook the food, they hand the ticket back to the chef, your service layer. The chef knows the recipe, but needs ingredients, so they go to the pantry, your repository layer, to grab the raw data. That data flows back up the chain to the client. This strict separation of concerns is the ultimate secret to a code base that can scale.
Here is a golden rule you absolutely need to live by. Keep your controllers incredibly thin by delegating all the heavy lifting to the service layer. I cannot stress this enough as a senior developer. Do not let your waiter cook the food. If you are writing if statements, calculating totals, or formatting dates inside your controller, you're breaking the architectural pattern. The controller's only job is to validate the incoming HTTP request, pass the data to the service, and then wrap the service's result in a proper HTTP response, like a 200 OK or a 201 created. That is it.
Moving down into the service layer, here is a pro pattern you really need to adopt. By separating your service into an interface and an implementation class, the controller never actually knows the implementation details. Your controller simply relies on the interface, a strict contract of what the service can do, not how it does it. This is the dependency inversion principle in action. If you ever need to swap out the underlying logic, or if you just want to write a unit test for your controller without actually hitting the real service, having an interface makes the whole process completely seamless.
All right, down into the repository layer, our pantry. When you're setting up database interactions, you generally want to reach for JPA repository over CRUD repository for most applications to unlock those powerful built-in database operations. Spring Data JPA is incredible. You literally just define an interface and Spring writes the SQL for you. While CRUD repository gives you the basic create, read, update, and delete functions, JPA repository takes it up a notch. It gives you all of that, plus the ability to flush the persistence context, perform batch deletes, and easily paginate your data. It costs you absolutely nothing to use the more powerful interface, and it saves you massive headaches later.
As that data travels back up the chain to the controller, please remember this critical rule. Never leak your database structure to the client. You should always return DTOs, data transfer objects, instead of raw entities. Your entity class maps exactly to your backend database table. It might contain a user's password hash, internal status flags, or creation timestamps. If you return the entity directly from your controller, you risk accidentally exposing highly sensitive data. Plus, if you ever change your database schema, you instantly break your API contract with the client. Always map your entities to a specific DTO before sending anything out the door. Now, as your monolithic codebase inevitably grows, how you organize these layered components becomes crucial. You want to organize your packages by feature, creating fully self-contained modules. A lot of beginners organize their folders strictly by layer, all controllers in one folder, all services in another. But in a massive project, this means you're constantly jumping across the entire codebase just to work on a single feature like orders. Instead, package by feature. Put the order controller, order service, and order repository all in one order package. This keeps related code physically close and prevents your domains from bleeding into one another.
By sticking rigidly to this clean, feature-based layered architecture, you're not just writing good code today. You are literally planting the seeds to extract microservices tomorrow. Think about it. If your feature is entirely contained in one package, with thin controllers, interface-backed services, isolated repositories, and strict DTOs, extracting that into its own separate Spring Boot application is basically as simple as copy and paste. So I'll leave you with this. Looking at your current project, if you had to pull out your core feature into a microservice this afternoon, could you actually do it, or is it completely tangled in spaghetti? Start organizing your code like it's a microservice today, and I promise your future self is going to thank you.